Hi, in this session I'll introduce you to the key components of the equipment used to provide inhalation sedation. I'll talk in more detail about the components that make it safe to use on our patients, as well as those features that make it safer for staff to use nitrous oxide long term. Throughout this I'll be focusing on the portable system that looks like this, but I'm conscious that a lot of you will work in places where the equipment looks very different, like this, or this. So first things first, what's it called? RA machine? In your clinics, you'll probably hear this term used quite a lot. It's really not ideal to use the term RA anymore. It's quite an antiquated term, and also it doesn't lend itself to easy explanations to patients of exactly how we're going to be providing sedation. Also, there's a lot of different features within here and a lot of different components, and you need to know what they are and how they all fit together, because the system where you work might look quite different to this. Despite the apparent differences, all systems are simple and comprise the same 5 components. There's the gas supply, there are reducing valves that take the pressure of these bottled gases down to a safe and workable level, which is also known as a regulator. A flow meter, also known as a mixer head or flow control head, is where we select the rate and relative concentration of the gases to provide to the patient. The breathing system takes this gas mixture to the patient and then takes the gases away from the patient to the scavenging system. Irrespective of what your system looks like, your gas supply will be from gas cylinders. For those of you using a portable system, the gas cylinders are obviously in front of you and you'll be responsible for maintaining and changing these. For those with a centralised gas supply, it may be non-clinical staff that are responsible for maintaining the cylinders, which are generally much bigger and somewhere else in the building. Again, for the pipe gas system, the regulator or pressure reducing valve is located out of the surgery, in the same room that the gas cylinders are. However, in the portable system, it's located just here. The flow meter or mixer head can vary in appearance, and there are digital ones which are a little bit more white clean, or the majority of them look like this, which is very similar to what an anaesthetic machine might have looked like 100 years ago. Apart from these have a few really important safety features to keep our patients from getting into trouble. There are a variety of breathing systems available, with a varying degree of disposability versus reusability. Clearview is one that's used in a lot of dental hospitals, and the Porter-Brown system is used quite a lot within the PDS. And there's some slightly newer, different looking systems like the Silhouette mask available. These all have what we call a nasal hood, a set of pipes that deliver the fresh gas to the patient and a set of pipes that take the exhaled gas away from the patient. It is the removal of these exhaled gases that we call scavenging, and every breathing system now used has to be compatible with an active scavenging system. If you use a portable system, then your scavenger may well look like this, which is what we call a mini scav. Whilst pipe systems, in the clinic, the scavenging system just tends to look like a wall outlet like this. They're exactly the same though. They both provide a 45 litre per minute vacuum to remove the exhaled mixture of oxygen, carbon dioxide and nitrous oxide away from the patient and eject that out of the building. It's this, combined with a well-fitting mask and good patient management, that keeps sedation staff safe from the effects of chronic nitrous oxide exposure, which would otherwise be very harmful to their health. So let's go through those components again in a little bit more detail in relation to the portable system. So this is our portable system here. We've got a stand, we've got 4 gas cylinders, each attached to the top at the yoke. These pressure gauges here measure the pressure within the gas cylinders when they're open. The pressure reducing valve, also known as the regulator, is attached underneath here and here for each side. and that reduces the system pressure to 45 psi for each gas going into the mixer head. The mixer head allows us to titrate to our patient's needs and select the gas mixture that's going to be breathed in through the inner mask. The outer mask is where the suction is effective and the exhaled gases are taken away from the patient through into the scavenging system and outside the building. Got the reservoir bag here as well, an obvious feature which helps us monitor the effectiveness of the seal of the inner mask. On the portable system, we have 2 oxygen cylinders and 2 nitrous oxide. At the start of any treatment session, we should ensure that 1 cylinder of each gas is full, as a backup in case the in-use cylinder runs out, thereby saving any unexpected interruptions to the treatment session. So the cylinders you see on the left side of the screen, which are blue, contain nitrous oxide. And the cylinders on the right are black, with a white border, and they contain oxygen. This colour coding system is going to change, however, so that by 2025 the body of all cylinders will be white, and it'll just be this top area called the shoulder which will retain this distinctive colour coding system. All 4 cylinders are the same size, which is called size E, which means they have an internal volume of roughly 5 litres. However, as their contents is pressurised, they release hundreds of litres of gas. When we connect to the fresh nitrous oxide cylinder to the yoke and open it up, it will read 750 psi on this gauge. Actually, it's only the pressure of the top 10% of the cylinder, below which is liquid nitrous oxide. As we use up the nitrous oxide gas component, it's replenished from the liquid phase below, meaning that the gas pressure is maintained at 750 psi. It is only when all of the liquid phase has been expended that the gas pressure on the nitrous oxide cylinder will drop, and this happens pretty quickly just before the cylinder runs out. Therefore, dentists and nurses should keep an eye on the pressure gauge during treatment to ensure that they haven't run out of nitrous oxide. Oxygen has quite different gaseous properties. A full cylinder contains gas phase only and has a pressure of around 1900 psi. This means that the pressure gauge up here behaves quite differently, much more like the fuel gauge on a car. A lower pressure indicating that the gas is nearly empty. For clinical staff, the most danger that could come from inhalation sedation would come from doing something wrong in the fitment of a gas cylinder. Remember, these are both highly pressurised gases and also both very much support combustion. With this in mind, your health board will have medical gas training for all clinical staff involved in handling and changing of cylinders, which you should do, and it's usually in the form of Learn Pro. One of the things you'll learn about is this little gasket here. This is called a Bodoc seal. This is crucial to maintain the seal between the cylinder and the yoke. You'll know if something's wrong with it because as soon as you open up a cylinder there'll be a very loud hissing of gas, and they can very easily become attached to old cylinders but also can get a bit worn with time and need to be replaced. One other very crucial thing is that the Bodoc seal doesn't get contaminated with oils of any sort. Oils can happen in hand creams and also food residues as well. The reason why that's important, when you open a gas cylinder, the Bodoc seal is subject to an extreme temperature change, and that hydrocarbons in the oil could potentially spontaneously combust, which when attached to either gas would be a problem. So provided we wash our hands, the equipment is very safe to use. From the properties section, you'll remember that nitrous oxide has a very high MAC. That means it's an anaesthetic drug of low potency with a wide margin of safety. That means it's an excellent drug for dentists to safely sedate their patients with. However, given alone, nitrous oxide could and would kill patients, and that's because they'd be hypoxic and weren't getting enough oxygen. With this sobering thought in mind, there are a considerable number of safety features built into the equipment here that prevents that from happening and ensures that patients always get oxygen, even if the oxygen supply in the tanks runs out. The first of these features is the pin index system, and this is designed to prevent us attaching the wrong cylinders to the wrong side of the machine, i.e. we can only attach nitrous oxide cylinders to this side of the machine, and that has to be oxygen that's attached to this side of the machine. That's because there are two notches within each gas cylinder that correspond to pins that are present within the yoke and mean that only these cylinders can be attached to the respective sides of the machine.
You can see the different configuration of notches between oxygen and nitrous oxide cylinders in this picture.
The next system that ensures our patients always get enough oxygen is by ensuring that the right cylinders connect to the right port on the mixer head. And this is called the diameter index system, and means that from a pressure reducing valve you can only use a specific nitrous oxide tubing to connect to the threads on the mixer head, and similarly at different size threads for the oxygen connection. There's a corresponding feature on the piped gas systems which is called BIS, and that means that the probes where you attach the mixer head to the wall only fit with the corresponding tubes, which are a diameter system again. So here we've got the mixer head. We can adjust the total flow rate to the patient using this flow control knob. The only other adjustment we can make at the mixer head is to change the relative proportions of each gas using the mixer control dial. The total flow rate to the patient stays constant whilst we adjust this nitrous oxide proportion up and down. The amount of nitrous oxide flowing per minute is displayed in this flow meter on the left hand side of the mixer head. The oxygen flow meter is on the right. We'll talk in more detail about the adjustments you need to make to these controls in the section on administering sedation. There are a further 3 safety features within the mixer control head which ensure our patient always gets enough oxygen. The first of these is demonstrated in the mixture control dial. The units on this is the percentage of oxygen. We always start off with 100% oxygen, and we also finish each treatment session in that way too. Throughout titration, we're increasing the percentage of nitrous oxide the patient breathes, and so the percentage of oxygen reduces. However, the equipment will only go as far as 70% nitrous oxide, which means that the patient will always receive at least 30% oxygen, which is more than room air. The next safety feature is this, the air entrainment valve. This ensures that the patient always gets a supply of air, even if the flow rate coming out of the system is insufficient to meet their minute volume. There are a few reasons why this could happen. One is if the flow rate that we've set using the control knob is insufficient to meet their minute volume. Or if the patient takes a series of excessively deep breaths, for instance during the anxious times of administering local anaesthetic. Another situation, although less likely, is if the gas supplies have cut out. For instance, if you've run out of oxygen in your cylinders. Both scenarios will be obvious to the clinical team, as the reservoir bag will be completely sucked flat like this. You may also notice the patient becoming less sedated. That's because they're now breathing room air rather than the gas mixture that you've set for that. With this in mind, sedation staff should be attentive and proactive to setting the flow rate appropriately to their patient, and also managing their patient's behaviour to ensure a consistent level of sedation. The final safety feature integral to the mixer head is that of the oxygen failsafe, or nitrous oxide cutout, depending on how you look at it. If the in-use oxygen cylinder becomes empty, then the nitrous oxide will stop flowing as well. So rather than the patient breathing exclusively nitrous oxide, the feature cuts all fresh gas, and so the air entrainment valve then kicks in and the patient is breathing room air instead. This cutout is clearly demonstrated in this video. Here you can see the mixture is set at 50%, and both gases are flowing at 3 litres per minute. When I disconnect the white oxygen probe from this piped gas system, both the oxygen and the nitrous oxide flow meters drop to 0. Once I reinstate the oxygen supply, both gases return to their previous flow rates. Some people consider this button here another safety feature. It's an oxygen flush. What does it do? It releases the full 45 psi from the oxygen pressure reducing valve through the machine and down the patient's nose. Could it be used in an emergency? Well, some sedationists say that yes. If a patient is over-sedated, then get them more oxygen by pressing the button. However, as soon as you stop pressing that, the predetermined gas mixture will continue to flow. It's also not particularly pleasant to have that pushed down your nose. It'll really reduce the patient's sedation, not only because of its action of decreasing the nitrous oxide, but also because it's just really unpleasant. So, we don't tend to say that the oxygen safety flush is a safety feature. We say good patient monitoring and adjustment of the gas mixture. So there we have it. That was a brief overview of the inhalation sedation equipment, the safety features that are designed to keep the patient safe, as well as keeping staff safe as well. The equipment that you use will be potentially different from what we're talking about here, so that's part of the mentoring to experience that. The setup is crucial. Your team locally will have a setup guide, or there are some available on the ramedical.com website to ensure that you set the equipment up, and every time you use it you check those safety features. Also, at the end of every session you ensure that the equipment is appropriately decommissioned so that you're not potentially leaving the building liable to burning down.